Now I'm going to talk about Gaussian quadrature. Now basic form of the Gaussian quadrature formula is given by a to b fx dx is equal to I is equal to 1 to n wi and fxi. Now if n is equal to suppose 2, okay, now what will be the Gaussian formula? Okay, so here the wi, where fx is actually function being integrated, and xi here, xi are the quadrature points and wi are the corresponding weights, and n is the number of points used in the approximation. Now if n is equal to 2, so what will be the formula? So that will be w1 f of x1 plus w2 f of x2. Now we need to know what is x1 and what is x2, and then what is w1 and w2 value. If we know that, then we can easily calculate the integration a to b fx dx, that I will discuss in the consecutive slide. Now here, okay, so by substitute, so okay, fine. Now to apply Gaussian quadrature to general interval a to b, a linear transformation is often employed to map the interval 1 to 1 to desired interval a to b. Now suppose interval is given like a to b fx dx. Now to apply Gauss quadrature, so we have to transform the interval like minus 1 to 1 fx dx. So that transformation is required, and then we can do the Gauss quadrature. Now how do you map that? So for that we need to transformation equation. So in transformation equation is like that: x is equal to b plus a by 2 b minus a by 2 zeta, where zeta represents the variable in the transform interval minus 1 to 1, and this transform equation allow us to work with standard interval minus 1 1 integrating over a to b. So now you have to remember, when we change the interval, so x will be b by a by 2 plus b minus a by 2 zeta. Now by substituting the transformation equation back into Gaussian quadrature formula, we obtain modified formula for Gaussian quadrature with the linear transformation. So we know that x is equal to, already we know that. Now we have to put all this, and then if we put all this, so ultimately we will get the formula. So that formula is, remember that, integration a to b fx dx. So b minus a by 2 summation of wi, and this is the x, so we have transferred this x, so this x will be b plus a by 2 minus b minus a by 2. So what will the change is here, so this is the change, b minus a by 2 into summation of I is equal to 1 to n wi f of, and this x, b plus a by 2 plus b minus a by zeta I. Okay, now zeta I has some standard formula. So where zeta I are the quadrature points in the standard interval of minus 1 to 1, and modified formula allows to perform Gaussian quadrature on any interval a to b, transforming it to standard interval minus 1 to 1. So ultimately we have to change the interval to minus 1 to 1, and then fx and dx. Okay, then we have to get that by using Gauss quadrature of this formula. Okay, now this is the about Gauss quadrature. Now what are the that points, what are the points value wi and zeta? Okay, so number of points, so if we only do, so there are many number we can take. So here I am giving only 2-point formula and 3-point formula. For 2-point formula, quadrature points value xi value is minus 0.577 this value, and plus 0.57735 this, and 3-point value, that xi value will be minus 0.774596669 and 3 points, okay, 0 and 0.77459, and weight function for 2 points, that is 1 1, and for 3 points, so 0.5556 0.88889.556. Okay, so using this point value, so we can calculate the integration. Now here I am showing one example. Now Gauss quadrature with 2 points. Okay, using 2 points, how do you calculate? Okay, now we know that using 2 point -1 1 fx dx, so that will be w1 fx1 and w2 fx2, and we know what is the w1 and what is the x1 x1 value. Okay, so quadrature points, so as I am taking 2 points, so xi value are -5 this and 0.577 this, and weighting function is this and this. Now here example is, consider the function fx is x square. Now we want to find out the numerical approximation integral fx over the interval -1 to 1. So already 1 to 1 interval is given. Okay, so we don't need to change the interval, so directly we can use the Gauss quadrature method. So w1 f1 fx1, w2 fx2. Okay, now we know that 1 dot, okay, w1 is 1, that f of x1 is this value minus 0.577, and f of x2 is this. Now f x is actually x square. Now we have to calculate the value. So f of minus this, so that will give 0.333 something, f of something, f of 0.57753, so that will be 0.33 some this value. Now -1 to 1, so that will be give, okay, so 1.033 something into 1 into this, so that will give 0.666. Original integration is 0.33, so that if you take 2 points formula, so that integration will not be perfect. Okay, so we will not get exact value. So we know that I of 0 to, okay, -1 to 1 fx dx or fx dx, or here, okay, so that will be x cube by 3. Okay, so that will be what? So 1 by 3 plus 1 by 3. Okay, no, that will be 2 by 3, so that will give the perfect result. Okay, so that is 0.66, that is perfect result that will give. Okay, now if we take, okay, so if we take 3 points formula, so again, so 3 point formula -1 to 1, so w1 fx1, w2 fx2, w3 fx3. So similar way, so that w1, w2 and w3 values are known here. Okay, so that is okay, that we can, weighting function is given here for 3, 0.55, 0.88 this, and xi points are 0.07 this, 0 and 0.77. so using that we can, okay, that is not here, so we can put all these values. So w1 is this, fx is this, okay, if w2 is this, okay, that is not okay. Now if we plug all these value, so ultimately first we have to calculate f of minus 0.77, so that square, that will give this value, f of 0 square, so that will give 0, and this square, so that will give this. And now if we plug all these values, so this is w1 and this is fx1, w2 fx, sorry, and w2 fx2, w3 fx3. okay, so the w2 value is this, w1 value is this, and fx2 fx2 means 0, x2 is 0, so we can calculate that, and finally we'll get 0.3994, and original is 0.666. okay, so that has some error. Now we know how to use 2 point and 3 point formula for Gaussian quadrature. Now here we use Gaussian quadrature with 2 points, but here interval are different. Okay, so interval is like, so function is given, function is x exp minus x, interval is given 0 to 94, means integration is integration of 0 to 0.4 fx dx. okay, now we have to change, we apply Gaussian quadrature, so that we have to do -1 to -1, or here -1 to 1, -1 to 1, so we have to do that transformation. So that is -1 to 1, so that is fx dx. For transformation, we know x is equal to half of b minus 1 plus zeta plus b plus 2. Okay, so we have to transform that x. So if we transform, so x will be 0.2 zeta plus 0.2, so that x will get, okay, so a is 0.4, and if we do that, we get 0.2 zeta plus 0.2. okay, so that we transform x. Now as we are taking that 2-point formula, so quadrature point we know this value, and weight coefficient 1 1, and we know Gaussian quadrature formula for linear transformation. So a to b fx dx, b minus a by 2 I wi f, b plus a by 2 plus b plus a by 2 ei. So this is x, so that x we already got, so that is the value, and that quadrature point also know. Okay, now ultimately, so we'll have the 2-point formula. So 0 to 4 fx dx will be 0.4 minus 0 by 2 I1 to 2 wi into f of this. Okay, now that will be 2-point formula. So here that will be w1 and f of that zeta 1 plus 2 and 2. Now if I put all this value, 0 to 4 fx dx 0.4 by 2 1 dot f this value, okay, 0.2, and this zeta 1 value plus 0.2, and then plus 1 into f 0.2, again that zeta 2 value plus 0.2. now, and we know that fx is equal to x square. Now we have to calculate all this value of f of this and f of this. Okay, so here f of this actually we are calculating that is the value. Okay, sorry, this fx is actually x e to the power x. Okay, so x into e to the power x, that is the earlier. Okay, so that we are calculating here. So we will get that f of 0.2 of this function value will be 0.1390244 something. Now, and f 0.2 that 0.57730 plus 2, so that will give 0.1427. Now after doing everything, and if we plug a b everything, okay, so ultimately we'll get the value of the integration is 0.0569988,739, this value. Okay, so that will be we'll get. Now using that is Gauss quadrature 2 points formula. Similarly, we can use Gauss quadrature 3-point formula for this problem also. So if you have any question, you can ask me. That's it. Thank you.